Second, shh, thank you. Yesterday we were plowing along here, and we did a bunch of problems, and I got to this one, and I said, hey, do we have to be careful on this one? And we said, yeah, you can't plug in a 0, and then we started talking about domains. And then John said, well, what about this one right here? And we were looking at this one, and I was just looking at this, explaining, no, you can plug in anything you want. When really, see, I had all this stuff crossed out, wasn't even thinking about the original problem on that one. So if we came back here and considered the original problem and asked a question that it doesn't ask for on this one, do we have to be careful on this one with domain? Yeah, we couldn't plug in a t equals 0, right? Okay, so John caught that, caught me off guard there. So anyway, nice job there. Okay, bonus points for John. So let's turn our attention to the next section. It's on combining rational expressions. Yesterday we did multiplication and division, and we showed why that's easier than adding or subtracting. That's combining rationals, because you have to get a common denominator. So let's look at this in terms of doing this particular one right here. Now, if you were going to do 3/4 plus 1/10, most people would look at this and they'd say, well, we just need to get a common denominator. We're going to make both of those 40s. Okay, I'm going to do this differently. Okay, that works really well with numbers, but if you think in terms of the stuff that we're going to see later on, I'd rather you think of it this way. This is 3 over 2 times 2, and this is 1 over 2 times 5. The way we're going to make these denominators the same is we're going to make them have the same factors. We're going to make the denominators the same by making them have the same factors. In fact, that's the key to solving the problems on today's assignment. Make the denominators the same by making them have the same factors. So if I do that on this particular one right here, this one has 2 2's, this one has a 2 and a 5. What does this one need that this one has? It needs a 5. What does this one need that this one has? This is a 2. Now, if I multiply the bottom of this one by 5, I've got to multiply the top one by 5, so I keep it an equivalent fraction. And if I multiply the bottom by 2, I have to multiply the top by 2. Okay, now, if you do it that way, you'll actually avoid a mistake that a lot of people make. Did you catch what I said at the beginning? What did I say we'd use as a common denominator here? 40. Is 40 a common denominator? It is, but is it the smallest one you could use? It's not. 20 would be. And look, these two are the same. We're not even really considering what the number's going to turn out to be down here. We're just worried about making them have the same factors, because if they have the same factors, they'll be the same denominator. They'll be the common denominator. So this is going to be 3 times 5 plus 1 times 2 over, we don't change the denominator. It doesn't suddenly become something else. It's 2 times 2 times 5. That means I've got a 15 plus a 2 over 20, which is a 17 over 20, and there's my answer right there. Now, is that more difficult than doing this? Let's see, I'm going to make this a 20, so that's going to be 15 over 20. I need to make that a 20, so that's going to be a 2 over 20, so 17/20. I get the same answer, and this is easier if you're working with numbers. But if you're working with variable expressions like we're going to see later on, if you're working with things like this, it's a lot easier to think in terms of make them a common denominator, make them have the same denominator by making them have the same factors. Okay? So you've got to know what the factors are. Okay, are there any questions there? Okay. So we're going to factor the denominators. We're going to make all the denominators have the same factors, and then we're going to be able to combine them. Now, occasionally, they're already going to have a common denominator. It'll already be factored, and then it's not too terribly bad. So, for example, make 2/5 have a denominator of 10. I'm going to multiply the top by 2 and the bottom by 2. I get 4/10. That's what we call, again, the word is it's an equivalent fraction. It's the same. It represents the same number. 4/10 is the same as 2/5. Okay, we want to combine the two of these. We already have a common denominator. So the denominator is going to be 5 over n, and I add the 2 plus the 8. I put those together on the top. 2 plus 8, which is 10 over 5n. Do we leave it like that? We don't. Then it's like the problems that we did yesterday. This is 2 times 5. This is 5 times n. I can cancel those off, and the best way to write this is 2 over n. That's it. Okay, are there any questions there?
Question.
Yeah.
So if we get a problem like that, do we need a state domain?
No, not unless it tells you to. Okay. I'm proud of you for thinking domain. Okay. You should be aware of that. And again, you'd want to be aware of the domain not in the simplified version, but in the original problem. Okay. But let's not worry too much about that unless they ask us to. Keep it in mind, but there you go. So we want to go ahead and combine these. We get lucky on this one. We already have a common denominator, so this is going to be y minus 2. Okay, watch please. This is a very common mistake. 4y plus 2 minus y minus 3. What's wrong with that? Okay, you didn't distribute. So if you're going to do this, please write down that you're subtracting that entire top, put it in parentheses, or distribute it through when you multiply. So that would be a minus y, and a minus minus 3 would be a plus 3. Then we can go ahead and combine the like terms. So this is going to be a, this is going to be a y minus 2 in the denominator. This is 4y's minus 1y, so that's going to be 3y. And then 2 plus 3, so this is going to be a 5. That is the correct answer on that problem. Any questions? Sure? Okay. Everybody watch these next ones. These are out of the textbook. You have problems that are similar to this in Math Excel. I'm not quite sure why they do this. I think they're trying to make the problems easier, but in some cases this is more difficult. It says find the least common multiple of each pair of polynomials. Basically what that's saying is if those were in the denominator, what would you use as a common denominator? Because a common denominator is the least common multiple. It's the least common denominator. It's the smallest denominator you could use and still have it be the same. So here's what we do. I'd write this down as 2 times 2 times 2 times x times x. Let's write this one down as 2 times 2 times 3 times x times x times x times x. Now, if you don't have to write all that down, that's totally fine with me. But again, we're going to make these the same by making them have the same factors. So what does this one need that this one has? Okay, it needs a 3. Does everybody agree it needs a 3? Okay, and how many more x's? 3 more. Okay. On these problems, you could stop right there. That is our common denominator. It would be 3 times 8. That's 24. And how many x's do I have? 5 of them. Yeah. Okay. If these were denominators, we would. We'd have to put a 2 over here, and we've already got those right there. But if I multiply these together, I get 24x to the 5th. All they're saying is, if those were the denominators, what would my common denominator be? What would my least common denominator be? Okay. So I agree, it's a little bit on the confusing side. So let's take a look at this one. If you're going to make these the same, you have to find out what the factors are first. So let's go ahead and factor this. I need numbers that multiply to be negative 12 and combine to be negative 1. So negative 4 and positive 3. Tell me if I make a mistake here. This one is a difference of squares, so that's x minus 4 and x plus 4. What does this one need?
X plus 4.
Okay, so we need an x plus 4. Now, if you want to come over here and say, gosh, what does this one need? It needs an x plus 3. That's totally fine with me. I like the idea and everything. Again, these are kind of silly problems. Our common denominator is, oh my gosh, why write it again when you could circle either one of these? Okay? That's our least common multiple. That would be our common denominator, yeah.
Would we have to distribute?
No. Okay, and again, you wouldn't want to distribute because you want to leave, especially leave the denominator factored. Okay? Because then you can see what all those factors are, and once you get the numerator, you can factor that and see if you can cancel anything off. Leaving it in factored form on these is much, much better. Okay, are there any questions? Okay, let's take a look at the next ones. It says, perform the indicated operations, simplify when possible. So I take a look at these. I know I'm supposed to subtract them. I'm supposed to combine these. So the way I'm going to do that is I'm going to make them have the same factors. So I'm going to multiply this one by 2. So that gives me, let's kind of speed up the work here. Do I have everything I need? I've got the right number, but do I have the right number of variables? No, I need another y on this, don't I? So this is my common denominator. This is 18y squared. This is 18y squared. So that's still my denominator. Remember, that doesn't change at all. If you do 1/5 plus 3/5, you don't get 4/10. Okay? You get 4/5. So this is going to be 16y minus 5. Now, watch please. Okay, I've said this pretty much from day one. If you have subtraction in a problem, you need to be a little bit careful. There's only one term over here, so we just put the minus 5. It's pretty tough to mess that up. Now, can I cancel the 16 with the 18? Okay, Amelia's not here, so let's not do the marriage stuff. Why can't you cancel these?
Because they're one term.
Okay, this one is a term. This one is a factor. Okay, you cannot cancel terms with factors. Okay, you only cancel factors, not terms. Okay, same thing with the y and the y squared. So this is done. End of story right there. Let's look at the next one. If I'm going to make these the same, the first thing I do is I would factor the denominator. So I'd take out a 2, I'm left with an x plus 3. Does this one need anything? No. Does this one need anything?
Yes.
It does. It needs a 2, so I'm going to put a 2 on the top and the bottom. Now watch please. Another common mistake. Should I leave it like this? No, it's 2 times the entire top. So our denominator is going to be 2 and x plus 3. And our numerator, we get an x minus 3 plus a 2x plus a 4. So what would be the best way to write that? Simplify. I'm going to add those together. That's going to give me a 4x. I'm going to combine those. That's going to give me a 1. And the denominator is still 2 and x plus 3. Oh, 3x. Thanks. 3x. Put these together, 3x. Put those together, you get a plus 1. Should I leave it like this? Yes. Leave it like that because with the denominator factored and the numerator, you can't take anything out of a 3x and a 1 other than a 1. You still wouldn't be able to cancel anything off. Okay? If we leave it like that, everybody can see that it's in simplified form. Questions? Okay. Bottom of the first page, let's take a look at those. These get a little uglier. So I'm going to zoom in on this one right here, and let's see if we can get this one. So this would be 3y plus 2, and our denominator is y and a y, multiplies to be negative 24 and combines to be positive 5. So I'm going to say positive 8 and negative 3. Little word to the wise. Take 3 seconds and make sure you factored it right. Do they multiply to be negative 24? Yep. And do they add up to be positive 5? They do. Okay. And then this one right here, this is going to be y and y. I need numbers that multiply to be negative 32 that combine to be positive 4. Positive 8, negative 4. Double check. Multiply to be negative 32, combine to be positive 4. I've got the right ones. Now all I have to do is get a common denominator. What does this one need?
Nothing.
Y
Careful.
minus
It's got a y plus 8 and y plus 8. This one has a y minus 4, so this one needs a y minus 4. I'm going to put that on the top. This is the first one we've run across like this. Once I put that up here, Remember, I'm multiplying the entire numerator by y minus 4, so put the entire numerator in parentheses. What does this one need then? This one needs a y minus 3. Now, if you've got just a plain old monomial, if you've only got one term in the numerator, the multiplication is going to be pretty easy. So here's what I've got. My denominator is y plus 8, y minus 3, and y minus 4. Does it matter the order I write them down? Doesn't really matter, okay? Here I get, let's be careful on this, when I multiply here, I get 3y squared. When I multiply here, I get minus 12y plus 2y, and then minus 8. And what do I get from this stuff over here? I get plus 7y minus 21. Now, this stuff came from that yellow one. This stuff came from this one right here. Because this is a plus, you don't have to be quite as careful. If that had been a minus, what would these numbers have been? Negative 7y and positive 21, because a negative 7 times a negative 3 would have been a positive 21. Okay, are there any questions there? Are we done? No. Not done, because we need to combine these, make this look as simple as possible. The good news is when the denominator is already factored, we're in great shape. So I can just write that down again. Let's take a look at the numerator. I've got a 3y squared. Done with that one. Okay, I crossed it off so I could still see what I had. I have a minus 12y, a plus 2y, and a plus 7y. So that's a positive 9y minus 12y. So that's going to be minus 3y. Done with those y's. And then I'm looking at these two right here. Let's see. That is negative 29. Okay, are we done? Combining fractions is a pain in the butt, especially when they're rational expressions with variables on the top and bottom like we've got here. Polynomials. We've got a trinomial right here. We ought to check this to see if maybe we could factor it and cancel it off with something in the denominator. So let's do this. Let's multiply. Well, first of all, you can't take a 3 out, right? So let's multiply the 3 and the negative 29 together. That's going to be negative 57. Are there numbers that multiply to be negative 57 that combine to be negative 3? Okay. You've got, let's see. Oh, that's not 57. It's 87, isn't it? 87. You got 1 and 87. 3 goes in there. How many times does 3 go in there? Well, my gosh, that's 29. 4, 5, does 6 go in there? Nope. 7? Nope. Nothing else goes in there. So the good news is, because the numerator is prime, it's factored completely and we can't cancel anything off. So that's our answer. Any questions? Okay. Some of them get a little ugly. Let's take a look at this next one. See how bad this one is. You just immediately start factoring this. So this is x minus y and x plus y. We've got a 6xy here. We're going to need to be careful on this one because this is a minus. So this is going to be x plus y. If I were you, everybody watch please. When you write this down, I'd go ahead and put that in parentheses because odds are that's going to be helpful. The denominator is already factored. Does this one need anything? What about this one? This one does. It needs an x plus y. Now, this is where if you memorize those patterns that we worked on in the last chapter, you're going to be in good shape. The denominator is still x minus y and x plus y. I get a 6xy here. And then I get a minus. Well, here's what I would do. Because it's minus all of this stuff, let's figure out what it is first of all. When I multiply these together, this is a perfect trinomial square. It's going to be x squared plus 2xy plus y squared. What happens when I distribute the negative through to all three of those? all three negatives. So negative x squared, negative 2xy, minus y squared. So if I rewrite this, I have minus x squared plus 4xy minus y squared over x minus y and x plus y. And at this point we roll our eyes because we've got to look at that and say, well, wait a minute, maybe that factors. But does it? Yeah.
Did we miss something? The 6xy?
I put that together with the minus 2, that's why it's a positive 4. Yeah. But thank you for checking me.
What if anything, that one factor, should we just take out negative 1 so the leading coefficient is not negative?
So Zach makes a good point. Could we take out a negative so the leading coefficient is negative? You could, but it's not going to cancel anything down with anything down here. So if you were to look in the back of the book on a problem like this, I would bet that would be the answer. Okay, with one caution. What if this started with a negative and one of these was written in the wrong order? Like say maybe this was a y minus x rather than an x minus y. You could factor out a negative out of the bottom and the top, then cancel those, then it would look better. Okay? So if they're both in the wrong order, or they both could, you could factor a negative out of both of them, that might be a good idea. Okay, any questions? Oops. Okay. Then let's think about these problems right here because these are kind of interesting. Okay, so that first page, you could do the assignment by looking at that first page. But let's look at this one right here. I can make these have the same denominator by making them have the same factors. Because I could just make that a negative and make that a negative, right? So then I'd have a negative p as my common denominator. Does anybody see another way to do this particular type of problem? Zach?
Couldn't you just float the negative up and subtract or cancel it out?
Okay, so Zach's going to float the negative up. Okay? I think I mentioned this before. There are three ways to write a negative fraction. So if I have negative 3/4, I can write it out front, I can write it on the top, or I can write it on the bottom. I just can't write it on the top and the bottom, right? Well, this is a negative fraction here. I've got the negative on the bottom. I've got two other choices. If I move it on the top, it would be a minus 7. What if I moved it out in front? It would make it a plus, right? So let's do that. Let's make that 8p minus a minus is a plus, 7 over p. So my answer is 15 over p. Quite a bit easier and a better answer that doesn't have to be simplified than if we were to get a common denominator by making both of those negative. Okay? Let's look at this one. Ready? What's wrong with this? A lot of times I put a little asterisk by these. John?
Yeah, well, it's the same thing as the problem before. It's b minus a instead of a minus b. So b
Okay.
plus
It is going to turn into the same thing as before because this is in the wrong order. So I'm going to rewrite this as a squared and a minus b. Then I'm going to write plus b squared. I'm going to write minus a plus b. Now, do we normally like this starting with a negative? No, we don't. And we also don't like it because it doesn't match what we've got over here. So if I take out the negative, here's what I've got. Taking out a negative gives me a minus b. Oh my gosh, that's the same as over here. And what can I do with this negative, according to Zach? Float it up there. Let's change this so that it's a squared over a minus b squared over a minus b. We have a common denominator. So that's going to give me a squared minus b squared over a minus b. Does anybody recognize that? Difference of squares. A minus b, a plus b over a minus b. So what can I do? Cancel these off. So my final answer on this one is a plus b. After this big ugly mess, I just get a plus b. Good there? Okay, take a look at this one. Okay, I think I've mentioned this before, but if I haven't, if there's a fraction in a problem, you might as well think of everything as a fraction. So is 3 a fraction?
Yes, 3 over 1.
3 over 1. We're going to make it look like a fraction. It needs the same denominator, so it needs a y minus 5 on the top and bottom. So this is going to be y minus 5 on the bottom. This is going to be, let's see, what do we got there? 3y minus 15 plus y plus 2. So that's going to be 4y minus 13 over y minus 5. And clearly you can't do anything with that, right? Any questions? Okay. Just about done. Take a look at number 71. It's 3 terms that need to be added together. So if we were going to do this one, we'd have to get a common denominator here. So we better factor. So that's going to be numbers that multiply to be 6 that combine to be 5. So that's going to be 3 and 2. This is going to be, let's see, I need numbers that multiply to be 2 that combine to be 3. So that's going to be 2 and 1. Correct me if I make a mistake. Minus, let's factor this right here. So this is going to be, let's see, multiply to be 6, add up to be 5. That's going to be 3. Well, wait just a minute. Haven't we seen this before?
Same thing.
Look at this. This is exactly the same as that, isn't it? So if I have one of these and I subtract one of these, what's my answer to this one going to be? It's going to be this middle thing right here. So it's going to be which, plus or minus? Minus 2 over x squared plus 3x plus 2. So don't just blindly put your head down and plow forward. Although we would get the right answer. If I were to do the problem this way, I'd need, what would I need here? What does this one need?
X plus 1.
Let's look through here. It needs an x plus 1. So I need an x plus 1 on the top. What would I need here? I need an x plus 3. So I multiply the top and bottom by x plus 3. What would I need here? I need an x plus 1. So I multiply the top and bottom by x plus 1. Okay, John.
Would you factor out the denominator and cancel?
What do you mean?
Like, have it x.
Oh, would I factor this? On one that's this simple, there's no way the numerator is going to cancel with the denominator, but it wouldn't be a bad idea. Okay. If I were to finish this off, does everybody agree the bottom is going to be x plus 1, and then x plus 3, and then x plus 2? Is that all right with everyone? This is going to be x plus 1 minus 2, and whoops, I'll distribute through, 2x minus, right? And then this is going to be minus x minus 1. And take a good look here. There's an x, there's a minus x, there's a 1, there's a minus 1. If I kept on simplifying, I'd pull out a negative. Cancel those off, and look, negative 2 on the top, x plus 1 on the bottom, and x plus 2 on the bottom, which if you multiplied those out, wouldn't that be exactly the same thing? So would either answer be acceptable, factored form or not? Yeah. Okay. All right. Any questions? All right. So on the next section, these skills are going to be really helpful. I'm hoping you've seen this before. If not, make sure you pay attention to this because this will come up again and again and again. Okay? There are actually 3 parts to an exponent. Okay? You're really familiar with things like this. This just means use x twice, right? If I wrote this, 2 to the negative 4, well, 2 to the 4th means 2 times 2 times 2 times 2, 4 of them, right? What does the negative mean? Sorry, what? It means reciprocal. Okay, it means reciprocal. It means we're going to flip that over. Take it from top to bottom or bottom to top. So this means 1 over 4 to the second, or excuse me, 2 to the 4th. So this would be 1 over that same expression that I was writing down here. Okay, and we also have things called rational exponents. So I could write 3 to the negative 1/2. If that's the case, the negative means reciprocal. This is the exponent, and does anybody know what that is? Yeah.
Well, you put it as a square root.
It's the root. So there are 3 parts to every exponent. We normally deal with positive exponents. We don't often come across fractional exponents, but when we do, we better know how to work with them. Okay? The only thing we're going to need to worry about right now is what do we do if we have a negative exponent? So let's take a look right here. Does the negative 1 apply to the x, the 2, or both?
X.
Just the x. So the 2 is fine. It's going to stay on the top. This technically would be 1 over x, but it's a lot easier to just say 2 is fine. It's on the top. Move the x on the bottom. There we go. Does the negative 2 apply to the x, the 4, or both? Just the x. So the 4 is fine. Where do we leave it? On the top. We want to change the sign of the exponent, so we're going to move it from the top to the bottom, and it's going to be x squared. That's it. Okay, is there anything wrong with this AB right here? No? They have exponents of positive 1. It's just understood to be positive 1. That negative 2, it applies to both of these together. So we're fine with the AB. They stay on top. Where do we move this? On the bottom. And when we move it on the bottom, what happens to the sign of the exponent? It becomes positive. Okay, so that's going to be this expression right here. Anything wrong with the 3p squared? Nope. So it's going to stay up in the numerator. And this is going to move to the denominator, 3 minus p. Now, if I did this, is that okay? It's a little silly, right? What happens if I take that stuff and raise it to the first power? Just stays that stuff, right? So if you wanted to write it, you could, but this is the easiest way to write it. And last couple and we're done. It says multiply and simplify. Multiply and simplify. So we're going to distribute through here. So this is going to be 9x to the third over x squared minus 18, let's see, x to the third, 3x to the third, and then simplify. I've got 2 x's on the bottom and 3 on the top. How many cancel? If I've got 3 on the top and 2 on the bottom, how many of them cancel? 2 of them. How many are left? Where are they? Are they on the top or the bottom? They're on the top. So I'm going to cancel this with that. I'm left with a 9 and an x, both on the top. 3 x's on the top and 3 on the bottom, so those are going to cancel. And I have an 18 over 3, so that's a 6. I'd just leave it like that. That's fine. We'll do this one the same way. This is going to be, let's see. I mean, if you want to cancel while we're doing this, that's fine. Sometimes that can get a little tricky. I'm going to go ahead and write 24 a to the second b to the fifth over 8ab squared. Plus 8, what? A cubed b to the fifth over 4b to the fifth. Then I take a look at each one of those and I simplify. What can I cancel to be 1? So I can cancel the 8 with the 24. This is a 1 and that's a 3. 2 a's on top, 1 a on the bottom, so I'll cancel this with one of those. 5 b's on the top, 2 b's on the bottom. These 2 will cancel with 2 of these. How many would be left? You're all working ahead, right? So that'd be 3. So this is going to be 3ab to the third. And then plus 8 cancels with the 4. It's a 2. Is it top or bottom? Top. Nothing to cancel the a's with, so that would be an a cubed. What about the b's? Cancel completely. So those are gone. Those cancel to be 1. These cancel to be a 2 on the top. And that right there is our answer. Okay? Please make sure you're aware of how negative exponents work. Okay? Take a look at those again if you need to. I think there are a couple review problems on your assignment. All right. Any questions? Okay, you've got about 15 minutes if you go ahead and get started on the homework. See